You know, there's a thing I was thinking about the other day, and it kind of stopped me cold. And I mean really stopped me. I was just sitting there with a cup of coffee, and I thought, light doesn't move. Not the way we think it does. Not really. And I know that sounds completely backwards. I know it does, because you can watch a flashlight beam, you can see it traveling. But wait, just wait. Because here's where it gets interesting. Let me start somewhere familiar. Suppose you're on a train, all right, a fast train, and you throw a ball forward. Now somebody standing on the platform watching you, they see that ball moving faster than you threw it. Makes sense. You add the speed of the train to the speed of the ball. That's just obvious. That's the kind of thing your gut knows without thinking. Fine. Now suppose instead of throwing a ball, you shine a flashlight. Same idea, right? You're on the train, you aim it forward, the light shoots out. So the guy on the platform, he should see that light going faster. Train speed plus light speed. That's what your gut says. But it doesn't happen. That's not what nature does. The guy on the platform measures the exact same speed of light. Not a little faster, the same, to 9 decimal places, the same. And this is not a small thing, you see. This is not some rounding error. It's the same, completely, utterly, stubbornly the same. And when I really sat with that, when I was a student and I first understood what that was saying, I just thought, well, something has to give. Because if the speed of light is always the same for everybody, then the things we thought were fixed, the things we thought were solid and reliable, those are the things that have to bend. And what bends? Time. Time bends. Now I know how that sounds. It sounds like science fiction. It sounds like someone made it up on a Tuesday. But let me try to show you what I mean with something a little more physical. Because I always need something I can get my hands on. Picture a clock. Not a digital one, a nice old clock with a mirror inside and a single photon, a little bit of light just bouncing back and forth between two mirrors. Tick, 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 that's the clock. Every time the light bounces, that's one tick. Now you're holding this clock, and for you the light is going straight up and straight down. Up, down, very simple, very clean. But I'm watching you from across the room, and you're moving, let's say, walking fast. So from where I'm standing, that little photon inside your clock isn't going straight up and down anymore. It's going up and sideways, tracing out a long diagonal zigzag. You see that? The path is longer. Now here's the thing. The speed of light is the same for both of us. We just agreed on that. So if the path is longer and the speed is fixed, then the time between ticks is longer. For me, your clock is running slower than mine. Your clock is running slower than mine. And I want to be honest with you here, because I think people often say this and then wave their hands and move on. But I'm not going to do that. I genuinely cannot give you a reason why nature decided to do this. I can tell you what it does. I can show you the math. I can show you it agrees with every experiment we've ever run. I can show you the GPS satellites in your pocket have to account for this every single second, or your maps would be wrong by miles. But why? Why is the speed of light the same for everyone? Why does time flex instead? I don't know. That's the honest answer. Nobody knows. That's not a gap we're embarrassed about. That's just where we are. Now let me come back to the original thing, because I got a little sidetracked there and I want to return to it. I want to return to what light actually is doing. You see, here's the curious part. From light's point of view, and I know photons don't have a point of view, I know that, but just play along with me for a second. From light's perspective, no time passes at all. A photon leaves a star 100 million light years away. It travels across the entire universe. It hits your eye, and from the photon's own experience, it was instantaneous. No time elapsed. Not a tiny amount. Zero. So in what sense did it move? If nothing experienced the journey, if there was no duration, no tick of any clock anywhere inside that photon, did it go anywhere? Or did it just connect 2 points in space and time like a single instant stretched impossibly thin across the universe? And now you start to wonder. You really do. I remember when I was younger, I used to stretch rubber bands, the kind you find in office drawers, and I'd think about what was happening inside. The little molecules all lined up and pulling on each other. You stretch it, they resist, they want to snap back. Very ordinary. Very tangible. And then you get to light, and suddenly the tangible stuff is gone. You can't stretch it. You can't slow it down. You can't run alongside it. You try to catch up and it still moves away from you at exactly 300 million meters per second. It doesn't care how fast you are. It doesn't even notice you. That is, to me, one of the most fantastically strange things in all of nature. That there should be this one speed, this one number that is the same for every single observer in the universe, no matter what they're doing. And that to protect that number, to keep that constant, the universe will bend time itself. It'll stretch and compress the experience of duration. It'll make two people looking at the same clock disagree about how fast it's ticking. rather than let the speed of light be different for different people. It's as if the universe decided one thing was sacred, one thing it would not negotiate on, and everything else, everything we thought was solid, time, distance, simultaneity, all of it, is just allowed to flex, allowed to be relative, just so that one number stays the same. And isn't that marvelous? That the universe has this one stubborn constant, and that the strangeness, all the beautiful strangeness of relativity, is just the universe's way of protecting it. I mean, I get a kick out of that. I really do, every time. So if you ask me, does light move? I'd say, it's not quite the right question. What light does is stranger than moving. What light does is connect. And along the way, it refuses to let time tell it how long that took. And I'll leave that one for you to think about.